was a kid, one of my heroes was a guy named Bob Riggle, because he had a car that could do something nobody else's car could do. Damn it! You all right?
A biology student in Florida cuts open the lungs of a dead snake and finds something moving. Not a parasite anyone expected. Not anything that belongs there at all. Whatever it is alive, it is red, and it is nowhere near finished spreading. That single dissection would eventually connect to a chain of events involving a Category 5 hurricane, a shattered reptile warehouse, 25 professional bounty hunters, a fleet of snakes wearing surgical implants, and a headline that keeps getting repeated online in a version that is not quite true, that Florida deliberately unleashed thousands of snake-killing creatures into the wild. The state did not do that. What actually happened is stranger, because nobody released this thing on purpose. It let itself in. To understand the creature at the center of this story, you have to go back to August of 1992, when Hurricane Andrew tore through South Florida as a Category 5 storm with wind speeds over 165 miles an hour. Andrew flattened homes, it flattened businesses, and on the outskirts of Miami it flattened a commercial reptile breeding facility that had been quietly supplying the exotic pet trade with Burmese pythons. Nobody has an exact count of how many snakes escaped that day, because nobody was doing inventory in the middle of a hurricane. What is known is that pythons had already been trickling into the Everglades for years before Andrew, released or escaped by individual pet owners who underestimated how big a cute hatchling could get. A Burmese python does not stay small. It can stretch past 16 feet and weigh well over 100 pounds, and plenty of owners who bought one as a novelty eventually found themselves with an animal too large, too expensive, and too dangerous to keep in a suburban house. Andrew simply accelerated a process that was already underway, dumping an unknown number of additional snakes directly into a landscape that turned out to be almost perfectly designed for them to thrive. The Everglades gave the pythons everything a predator could want: warm, humid, thick with cover, and absolutely loaded with prey that had never evolved any defense against a snake this size. Within a few decades, researchers estimate the python population in South Florida had climbed into the tens of thousands, though nobody can put a precise number on an animal this good at hiding. The snakes are ambush predators, camouflaged almost perfectly against marsh grass and murky water, and they can go long stretches without needing to move, which makes them brutally difficult to find even when you know roughly where to look. By the time researchers began seriously studying the population's effect on the ecosystem, the damage was already staggering. Surveys of small and medium mammals in python-heavy areas of the Everglades found population crashes of over 90% for raccoons, possums, and rabbits, and bobcat sightings had all but disappeared in some of the hardest-hit zones. When University of Florida researchers later cut open more than 1,700 captured pythons to study their diet, they pulled out the remains of muskrats, deer, wild boars, threatened wading birds, dozens of alligators, at least one domestic goat, and several house cats. This was not a snake nibbling around the edges of the food web. This was an apex predator eating its way straight through it. Florida tried the obvious response first: send in people to physically remove the snakes. Starting in 2017, the South Florida Water Management District launched what became known as the Python Elimination Program, hiring a rotating roster of up to 50 contracted hunters and paying them by the hour, plus length-based bonuses that scale up sharply for the biggest snakes. Around the same time, the Florida Fish and Wildlife Conservation Commission stood up a parallel operation called the Python Action Team, sending trained agents onto public lands with the same mission. Together, the two programs turned python hunting into something close to a real profession for a small, dedicated group of people willing to wade through waist-deep swamp water at night with a headlamp and a machete. The results were genuinely impressive by the standards of invasive species control. Within roughly a year, hunters across both programs had logged more than 3,600 captured pythons. By 2018, the Water District alone was celebrating its 1,800th removal, including a 17-foot, 5-inch, 120-pound female caught by a hunter working Miami-Dade County land at night. One hunter in particular, Brian Hargrove, became something of a legend in the program, personally responsible for well over 200 captures and once catching an 11-foot male by slowly creeping along a canal bank in the dark until he spotted a shape in the grass that did not belong there. The state also opened the hunt to the general public through the Florida Python Challenge, an annual competition that pays cash prizes and draws snake hunters from across the entire country into the swamp for a shot at bragging rights and a bonus check. None of it was close to enough. Even in the program's best years, hunters were removing a few thousand snakes against a background population that researchers estimated in the tens of thousands, expanding across more than 7,800 square miles of Everglades habitat. A python can lay between 50 and 100 eggs in a single clutch, which means the reproductive math was always working against the hunters no matter how skilled they became. By 2025, one nonprofit research group, the Conservancy of Southwest Florida, had documented over 20 tons of pythons removed from a single 200-square-mile study area going back to 2013, including a record-breaking 6,300 pounds in one season alone. That sounds enormous until you remember it came from less than 3% of the total infested area. Somebody eventually had to ask an uncomfortable question out loud. What does it actually take, in terms of native animals eaten, to produce 20 tons of python? The economics of the program are worth sitting with for a moment because they reveal just how seriously the state ended up taking this. Hunters are not paid a flat fee. They earn an hourly wage for time spent in the field, plus a length-based bonus structure that rewards bringing in the biggest, most reproductively significant snakes, since a longer female generally means more eggs prevented from hatching. On top of that, the Water District began offering monthly performance bonuses to its top-producing agents, effectively gamifying an already grueling job. Applicants had to prove they could operate independently in remote, roadless terrain, often for hours at a stretch, using GPS-enabled tracking software on a phone or tablet to log every capture location for researchers. More than 1,000 people applied for a program that maintains only about 50 active positions at any given time, which tells you something about how much appeal there is in getting paid to wade through alligator-infested swamp at midnight hunting a 15-foot invasive predator. Faced with a reproduction rate no team of hunters could outpace, biologists turned to a stranger tool. Instead of hunting snakes at random, they started using pythons to hunt other pythons. Researchers working with the Conservancy of Southwest Florida developed what is often nicknamed the scout snake or Judas snake method, and it works by exploiting the python's own biology against it. Male Burmese pythons will travel long distances during breeding season specifically to find a receptive female, following chemical trails that a human tracking team could never hope to detect. So biologists capture male pythons, surgically implant them with radio transmitters, and release them back into the wild, then simply wait and follow the signal. When the male eventually locates a breeding-age female, wildlife teams close in, remove the female, and in the process take out not just one snake but every egg she was carrying, sometimes 50 or more in a single clutch. The male, still wearing his tracker, is released again to repeat the process, season after season. It is a deeply unglamorous but genuinely clever approach, essentially recruiting the species' own mating drive as an informant, and it has become one of the more effective tools in the entire fight, since removing one breeding female can prevent dozens of future pythons from ever hatching. Even with scout snakes, detector dogs trained to sniff out python scent trails, and a growing arsenal of thermal cameras, researchers kept running into the same wall. Burmese pythons are simply too good at not being seen. Some biologists have openly admitted that in dense habitat, hunters likely walk within a few feet of a hidden python without ever noticing it. Technology and manpower were buying time, not winning the war. The detector dogs deserve a closer look because they represent yet another attempt to solve the same fundamental problem. Pythons are ambush predators built by evolution to disappear. A dog's nose does not care whether a snake is camouflaged against marsh grass. Handlers train scent dogs specifically on python odor, working them through test enclosures and then out into real Everglades habitat. An early trial suggested the dogs could locate snakes that human searchers walked directly past. The catch is that the environment itself fights back against every method equally. South Florida's wet season floods huge stretches of the terrain, scent trails degrade fast in extreme heat and humidity, and a dog working 8-hour shifts in 90-degree swamp conditions has real physical limits that a thermal camera does not. Every tool in the arsenal, human hunters, scout snakes, dogs, cameras, ends up compensating for a different weakness in the others, which is exactly why the state kept layering new methods on top of old ones instead of ever finding one silver bullet. It's worth pausing on just how thoroughly the food web itself has been rearranged, because invasive predator can sound abstract until you see the actual numbers. Road survey studies comparing python-heavy areas of the Everglades to areas outside the snake's range found raccoon populations down by roughly 99%, opossum sightings down around 98%, and bobcat observations that had all but vanished entirely in the hardest-hit zones. Rabbits disappeared from surveyed transects almost completely. This matters beyond the individual species involved, because raccoons, rabbits, and possums were themselves food for native predators like bobcats and Florida panthers, an endangered species already clinging to a fragile population in South Florida. When a python moves in and eats through the prey base an entire local food chain depends on, the damage radiates outward to species that never directly encounter a python at all. Wading birds, previously protected somewhat by nesting height, turned out to be vulnerable too, since adult pythons are strong enough climbers to reach nests that ground-based predators never could. And then, in a dissection lab, someone found a clue that the pythons themselves might be carrying their own undoing. In 2012, a researcher named Melissa Miller found something unsettling while examining a wild eastern garter snake in Florida. A parasite called Raelietiella orientalis, a pentastome, sometimes loosely described as a tongue worm, that lives in the lungs of its host. This parasite is not native to Florida. Its natural range is Southeast Asia, and its natural host, for millions of years, has been the Burmese python. When infected pythons began arriving in Florida decades earlier, either through the pet trade or through Hurricane Andrew's chaos, they brought this parasite along with them as an unnoticed passenger, the same way an international flight can carry more than just its listed cargo. Once established in the Everglades, the parasite did something that should have been impossible for a species-specific organism. It jumped hosts. By the time Miller published a follow-up study in 2020, she and her team had pulled more than 1,000 individual Raelietiella orientalis parasites out of over 500 native snakes, and the infection had spread across more than a dozen different native species, from garter snakes to pygmy rattlesnakes. Around the same period, a separate team led by biology professor Terence Farrell at Stetson University made a genuinely disturbing discovery of their own. While examining a dead pygmy rattlesnake, live parasitic worms began emerging from the animal's mouth. Testing on additional rattlesnakes turned up the same infection, and genetic analysis traced its likely origin back to Southeast Asia, the same regional signature carried by the python population. Follow-up research found the parasite was not just riding along in native snakes but actively harming them, clogging and damaging lung tissue in ways that can prove fatal, particularly in smaller-bodied species that never evolved any resistance to it. The most unsettling finding came later, when Miller's research showed the parasite had cut its dependence on pythons loose entirely. It had adapted to use other reptiles and amphibians, including invasive Argentine tagus and Tokai geckos, as intermediate hosts, which effectively freed it from needing tropical conditions to keep spreading. Pythons themselves are physically restricted from moving too far north because they cannot survive hard freezes. This parasite has no such limit. Researchers now describe it as decoupled from the very species that brought it to Florida in the first place, meaning it could keep expanding northward long after any given python population hits a climate wall. This is the detail that clickbait video titles keep flattening into something it never was, framing it as a triumphant biological weapon that Florida wildlife officials supposedly deployed on purpose. Nobody released this parasite. Nobody engineered it, tested it, or approved it as pest control. It arrived by accident, spread by accident, and its effects are genuinely a mixed bag rather than a clean victory. Yes, some evidence suggests pythons carrying heavy parasite loads may experience reduced health, and there is early speculation that it could eventually act as a natural check on the python population the way a disease can check any population over time. But the same organism is simultaneously infecting and killing native Florida snakes that had absolutely nothing to do with causing the python invasion in the first place. Calling it a hero would be exactly backwards. It is a second, quieter invasion riding on the back of the first one, and researchers are still trying to understand where it stops. Part of what makes this parasite so hard to simply cheer for is the biology of a pentastome infection itself. Raelietiella orientalis lives directly inside lung tissue, and a heavy infestation can physically obstruct a snake's ability to breathe efficiently, weakening an animal over time even when the parasite alone does not kill it outright. In a large, robust Burmese python, that kind of chronic burden might shave down reproductive output or long-term survival odds without being dramatic enough to notice from the outside. In a small native species like a pygmy rattlesnake, which is already a fraction of a python's body mass, the same parasite load can be catastrophic, which is exactly what Farrell's team documented when they watched live worms emerging from a dead snake's mouth. Researchers now track infection rates the way epidemiologists track a spreading disease in humans, mapping which native species are showing up positive, how far north the parasite has been detected, and how quickly prevalence is climbing in populations that had zero exposure a decade earlier. Some scientists studying the spread have specifically flagged concern for already threatened native species, including the eastern indigo snake, since a population under pressure from habitat loss has far less room to absorb an additional disease burden than a healthy, widespread species would. So if the parasite is not a solution, what is actually changing on the ground in the fight against the pythons themselves? As it turns out, the answer involves turning the snakes into an economic opportunity instead of just a pest. In 2025, Florida Governor Ron DeSantis highlighted a new partnership between the state's Python Action Team and a Miami-based company called Inversa, built around a straightforward idea. If you cannot remove pythons fast enough through bounty payments alone, give hunters an additional financial reason to bring in every carcass by turning python skins into a usable leather product. The company markets its material as a way to relieve pressure on traditional leather sources while simultaneously funding invasive species removal, effectively transforming what used to be a straightforward disposal problem into a supply chain. Officials credited the partnership with supercharging removal numbers, building on an initial $2 million state investment, and DeSantis publicly called for that funding to continue on an annual basis rather than as a one-time boost. It is a strange kind of poetic justice. The exotic pet trade is the reason pythons ended up loose in Florida in the first place, prized initially for the same skin and novelty appeal that made them popular as pets. Now that same skin has become part of the incentive structure paying to remove them from the wild. Since official tracking began in the year 2000, more than 23,000 wild Burmese pythons have been removed from Florida and formally reported to state wildlife officials, a number that has climbed steadily as hunting programs, technology, and now commercial incentives have layered on top of each other. The public-facing side of all this is the Florida Python Challenge, an annual event that turns invasive species removal into something closer to a statewide sporting competition. Anyone can register, complete an online training course on how to safely identify, handle, and humanely dispatch a python, and then head out into designated hunting zones for a set window of days, competing for cash prizes tied to the number and size of snakes brought in. The competition draws participants from well outside Florida, some driving or flying in specifically for the event, wading through the same